Hello everyone, welcome to this session number 9 on geospatial analysis using Python working with vector data as part of the ongoing training program on Introduction to Python Programming and Applications in Water Resources sector. In the first 8 sessions, we have seen how to install Python as part of Anaconda distribution on your systems. We have also seen how to make use of Jupyter notebooks, which we have been using in every session to write and execute code. We have also seen the basics of Python programming in the first 5 days, including data types, data structures, file and error handling, functions, loops, and control flow. We also had one session on object-oriented programming, and yesterday we had 2 sessions on working with pandas, which is a third-party package for dealing with tabular data. Please explore the further functionality of pandas, make use of datasets available with you. Uh, have a look at the documentation on the pandas portal. Along with there is also tutorials and getting started with pandas documents which are available. Have a look at them. Today we will be starting with the geospatial analysis using Python. We will be only covering the main aspects and seeing some examples. Maybe in future we will be conducting a program on advanced applications of Python programming. For working with vector data, we will be using GeoPandas, which is nothing but an extension of pandas with an added element of geometry to it. So let us start today's session. If you remember in the first session on course overview and introduction, we spoke about the importance of geospatial analysis in water resources sector. We spoke about how geospatial analysis can help water resources professionals and researchers in the field. To appreciate what we are doing, you need to have some basic knowledge about geographical information systems (GIS), the conceptual knowledge what is meant by GIS and what are the data file formats like shapefile, and in shapefile there are it is a vector data format for storing location information and attributes, and you must be aware that there are file extension file a group of files like .shp, .shx, .dbf, .prj, each for a specific purpose. Similarly, there are other file formats, GeoPackage, which is an open source format for storing both vector and raster data. So there are other geodatabase, etc. Then you must be also be having clarity about what is meant by a projection system, the coordinate reference systems, like how the coordinates on Earth, the latitude and longitude are related to the real locations on the Earth. We have this latitude and longitude is basically they refer to geographic coordinate reference system. Similarly, we have projected coordinate reference system where the x and y coordinates, they represent locations on the flat surface. Then you need to know what is meant by datum. We generally use the datum WGS84 datum, which approximates the Earth to an ellipsoid standard datum. Um, then you need to be aware of EPSG codes, the frequently used EPSG code like EPSG 4326, which refers to this WGS84 datum. EPSG stands for European Petroleum Survey Group, which originally published a database of all spatial reference systems. So you have to have this such basic knowledge of GIS projections, and also you need to be you need to have some knowledge about remote sensing. Remote sensing provides the key input for GIS. Now with we have having a multitude of open access satellite imagery available publicly data available data sets. We are having now the field is rapidly growing. Like we in future we will be having much more data sets, microwave data, very high resolution spatial data will become available. So you can conduct time series analysis. Um, you can think of quantifying or estimate assessing the various hydrological parameters, um, not just rainfall, we can even estimate evapotranspiration using energy balance method. There are algorithms for that, and you can validate such assessed hydrological parameters with the ground data, and you can prepare data sets for, and to close, and we have better closing of hydrological the water balance equation because of unavailability or lack of measurements of many hydrological parameter. We don't get the complete picture. So geospatial analysis can add to the conventional data measurement point data measurements to have better understanding of hydrological parameters. So that is the conceptual thing which you need to be aware of, the concepts of GIS and remote sensing. Then the question of, we also have seen the question of why do we need to learn programming, or why do we need to use programming, Python programming for geospatial analysis when we have access to uh, licensed software such as ArcGIS or open access, free and open source softwares like UGS, which is as good as ArcGIS. Now, we have we have answered that question also. Basically, you want to understand the how the operations, geoprocessing operations actually work instead of clicking a button on your software. Moreover, your software will not be able to deal with a series of data. You can have at any time, we can work with any finite number of layers. However, if you want to automate workflows, you want to do a change detection analysis, or you want to have a time series plot, or say 30 years or 20 years, or even short term 5 or 6 years, it will be difficult using GIS software. If you want to mosaic various tiles into and you want to do that mosaicing operation all the time, for such things you need to know programming. You need, because and moreover, this you will understand the concept, underlying process, and moreover the third party packages which they are making it easy for you, like GeoPandas, Rasterio. These are help us for doing the geospatial analysis. The third party packages, many of them we have installed on the day one. um, to name few, GeoPandas we will be dealing. GeoPandas has dependencies like Shapely for manipulation and analysis of geometric objects, then Fiona for file access, then PYPROJ for reference code for projection system. Then for visualization, we have seen the basic plots in Pandas using Matplotlib. We will try to have one session on Matplotlib. And then there are very good data visualization libraries, third-party libraries, Plotly, BOKE, HBOKE. Then there are many other libraries which will be very useful. Only drawback or only issue is with multitude of such uh, packages which are available for users. However, some of them become very popular, some will become will fade away. Like we have pandas, GeoPandas. These are very popular, and they are being used by everyone. It has an support of user community, a thriving user community. So and we also have seen it is always better to install all packages along with dependencies in a dedicated environment for any project, and we have created one environment for this training program, though we haven't effectively used it till now. So you can continue from now on to explore these packages. You can see the examples and tutorials, and you can start working. So that is about geospatial analysis. Now coming to the today's topic, that is working with vector data. We will be using the GeoPandas third-party uh, Python package, which we have installed on the day one using Conda installer. It extends the popular data science library Pandas, which we have seen yesterday, by adding support for geospatial data. It is an open source project and to make working with geospatial data in Python easier. Now, GeoPandas combines the capabilities of Pandas for analysis of tabular data along with other packages, third-party packages, Shapely. We haven't installed Shapely or Fiona because they come along with GeoPandas. When we are installing GeoPandas, it will install along with its dependencies. So Shapely is for operations on geometry objects, points, lines, and polygons, which are the basic geometry objects. And there are multi-points, multi-lines, multi-polygons, which are combination of these. Then Fiona for file access and matplotlib for plotting. You can visualize by plotting your map on using matplotlib. GeoPandas enable you to easily do operations in Python that would otherwise require a spatial database. Now the core data structure in GeoPandas is GeoDataFrame, GeoPandas.GeoDataFrame. Now this is a subclass of Pandas data frame, which we have seen yesterday. The GeoPandas GeoSeries, which is a singular column of geo data frame, which is a subclass of Pandas series, which handles the geometry. Geodata frame is a combination, as I said, it is a combination of Pandas series. These are now you can see up to this part it is Pandas Pandas data frame having Pandas series, individual columns of same data type and the combination of them and having an index. And this comes with this is the traditional data containing numerical data, Boolean data, text data, and then there is geometry, which is this is a geo series, GeoPandas geo series, which contains information about geometry, points, polygons, etc. There can be many number of such columns, geo series in a geodata frame added in addition, but only one of them will be active at any time. If there is only one geometry geoseries, it will be the active geometry. And the benefit is you can have the geometries specific to one coordinate projection coordinate system in a column. Similarly, you can have various columns. At any time, one column is active. All geometric operations are applied to geodata frame operate on this active column. Each geoseries has a geoseries.crs attribute. CRS is the short form for coordinate reference system. So it has an attribute stored in it which stores information about the projection system. So let us start working with the Jupyter notebook. I have launched the Jupyter notebook from Anaconda Navigator after changing the environment to Python-WRM and then launched the Jupyter notebook application, which has opened a new browser window pointing to the home directory. I will again go to the same folder, Python WRM, and then the notebook subfolder. Here I will create a new Jupyter notebook, and then I will rename and save it Geospatial Analysis Vector Data. So I have saved it. Now we all know that spatial data is represented by either vector in the by vector layers or raster layers. We have two data models, vector data model and raster data model. In vector data model, you have the representation in the form of points, lines, and polygons. and their attributes. And in raster data model, you have representation in the form of a rectangular grid with values which can be represented by numerical arrays. Shapely library is a dependency of the GeoPandas. It is for representing and working with individual geometries. There are functions inside Shapely for creating geometries and applying simple geometric operations such as intersection, union, difference, calculation of distance, centroid, area, length of a line feature, etc. So, however, the functions in Shapely, there are no functions in Shapely which can read data from a file or and create a data structure, geodata frame, or which can read data from a geodata frame and write it to a file. So, for dealing with the more complex data structures, we have GeoPandas, where you have the data structure of geo data frame and geo series. So GeoPandas is in a sense pandas plus Shapely, and for plotting we have Matplotlib. We have discussed that. So Shapely it can be used for creating geometries. We will see that now using specific functions. Um, at the first point, we have to import Shapely package. Package, because it is a dependency of GeoPandas, it has been installed when we installed the GeoPandas third-party Python package on the day one using Conda installer. So let us import Shapely. From Shapely, there is a submodule geometry, and there are functions inside Shapely.geometry. Let us import Shapely.geometry. So we have done that. Now there are functions for creating various vector layers, various geometries, point geometry, multi-point geometry, line geometry, which is known as line string geometry, then multi-line string geometry, then polygon geometry, multi-polygon geometry. We will see how to create these. Now, one thing that you need to keep in mind is Shapely doesn't have this notion of coordinate reference system or any it doesn't have any reference system. So let us try to create a point feature. Now we have imported Shapely.geometry. Let us define point 1. Let us define and assign a point geometry object to point 1, which can be created by Shapely.geometry, and let us use our tab completion feature. You press period and then press the tab key and see the functions which are available in Shapely.geometry. You will be having many functions like point, polygon, multi-line string, line string. So let us select the point creation, and you have to simply pass a point coordinates, like just a tuple. We have to pass a tuple inside this. I will simply pass 0, 0, and let me print point. So a point 0, 0 has been created. So if I want to create multi-point 1, that can be done by passing a list of coordinates, a list of tuples into this function import dot Shapely dot sorry, it is not import. Shapely dot geometry dot multi-point, then the function multi-point, you have to pass a list of coordinates. So let me pass -2 comma 0, 2 comma 0. For simplicity, let me pass only 2 points, or you can take one more, 1 comma 1. This is a list of the points, and let us print multi-point 1. So 3 points are created, which, as you can see, these 2 points are on the same horizontal line, and this is 1.1. So that you can create that way. Now line string, which is the line feature, it can be created using the function shapely dot geometry dot line string. You have to pass the list of coordinates, list of tuples, 0 comma 0. Let me pass 2 comma 0, 3 comma 3, 0 comma 5. That is a line string. Let us print it and see. So a line string is created by connecting these coordinates 0 0, 2 0, 3 3 and 0 5. Similarly, you can create a multi-line string, and you can create a polygon. Now let us create a multi-line string. I will define it as line 2 is equal to shapely dot geometry dot line string. Then we have to pass the list of coordinates -3 comma 0, -3 comma 0, 0 comma 2 and 2 comma 5. Let me check. So this is another line string. Now for creation of multi-line string, what I will do is I will pass line 1 and line 2 inside the multi-line string function creation. So we have multi-line 1 is equal to shapely dot geometry dot, we have the function multi-line string, and let us pass list of lines line 1 comma line 2, just as we can pass list of coordinates, but here I am passing list of lines. and then let's see. So you have multi-line geometry, which is a combination of these two, and these are intersecting. So let us also create a polygon and a multi-polygon. So for polygon, I will create polygon 1 using the function shapely dot geometry dot the function of polygon, wherein I will pass the coordinate lists. Say 3 comma 0, 0 comma 3, minus 3 comma 0, 0 comma minus 3. Then we have to give the endpoint the same as uh, start point for creation of polygon. So all points within this boundary line is the constitutes the polygon geometry. So let me print polygon 1. So this is a polygon 1 geometry. Similarly, I can create a polygon 2 geometry. To make it fast, I will simply change the numbers. Polygon 2. So you can see there is no concept of scale, or there is no concept of coordinate reference. But within one geometry, you will have the representation where you can have the context of where the point is with reference to one another. Now to create a polygon with a hole, we have to pass on the outer shell and then the inner holes, because there can be more than one hole within a polygon. We have to pass a list within the list. Let us see. So for polygon 3, I will copy the same thing. So within this function, I am passing a list of coordinates, which will be the outer shell. Then comma, I have to pass another list of holes within a list. In another list, there has to be a list of holes. I will pass only one list of holes, which I will take it as this. So this is the outer shell, which is a list of tuples, and inner holes, which is a list of tuples. Let me check by printing it. So we have this polygon, which is a polygon with a hole. We can define multi-polygon 3 is equal to shapely. Let me define polygon 4 first. Polygon 4 is equal to shapely.geometry.polygon, then 6 comma 0, 9 comma 0, then 9 comma 3. Okay, that is polygon 4. So let us define a multi-polygon, which is a collection of polygons. Multi-polygon 1 using the function shapely.geometry.multi-polygon. I can pass the list of polygons, say polygon 3 and polygon 4. So this is a multi-polygon which has a polygon with a hole and another separate polygon. So in this way we can create various geometries, and we can check the attribute by we can use the geom type attribute to check the type of geometry. For example, point 1 dot, you can press tab and see the attributes and functions associated. So this geom type will give you the type, so it is a point type. Similarly, we have line 1 dot geom type line string. We can get coordinates point 1 dot coords property. Actually, we have to list out it. List So this point 1, which we have defined at the very beginning by passing the coordinates 0 comma 0 to this function shapely.geometry.point. Now to get the coordinates as a list of the coordinates, you can use this coords function, and you can list out the coordinates. Similarly, you can list out the coordinates of line line 1 dot, we can list out the coordinates of line. In case of multi-string, we can multi line 1 dot. So in multi-line 1 is a combination of two lines, line 1 and line 2. So to get coordinates, you can get coordinates of each line separately. So you may first check the length if it is allowed. Yeah, you can first select the length, check the length of this multi-line string using this multi-line dot geoms. There are two. So to get the first part, coordinates of first part, multi-line 1 dot geoms, then you pass the 0, and you can list out the coordinates of this using, so you can verify the coordinates are 0 0 2 0 3 3 0 5, which are the coordinates of the line 1. Similarly, for line 2 you can list out the coordinates which are minus 3 0 0 2 2 5. Anyway, these are simple things of creation of geometry, which we should not spend much time on this. Let us see polygon and then we will go further. So if we see this polygon 1, polygon 2 and polygon 3 is the one which has interior, and polygon 4 is normal polygon again. So in case of polygon 1, let us check the, every polygon will be having an exterior, whether it has any interiors. It is returning 0, means this polygon has no holes in it. You can list out the coordinates of polygon exterior with this 3 0 0 3 minus 3 0 0 3 3 0, which we had defined at the beginning. Then you can check the length of polygon 1, polygon 3 interiors, which is not 0, means it has one hole in it. Then you can get the coordinates, polygon 3 dot interiors dot polygon 3 dot interiors 0 dot chords, which should give the coordinates, interior coordinates, and exterior coordinates are these are interior coordinates and exterior coordinates are so let us check in case of multi-polygon. In case of multi-polygon, let us check the length of multi-polygon 1 exterior sorry, you have to pass geoms. Now the multi-polygon 1 has two polygons. It is a combination of two polygons. So let us see multi-polygon 1 dot the first polygon is this one, and let us check the length of these interiors, which is 1. It has one interior. So let us list out multi-polygon 1 dot geoms 0 dot exterior these are the external coordinates of the first polygon, making the multi-polygon. Similarly, you can list out the interior coordinates. Interiors, because there is only one interior, so these are the interior coordinates of the first polygon in this multi-polygon. In this way you can get the coordinates, and you can also check the attribute of any geometry, type of the geometry, to this geom type attribute, and you can even print any, say if you print point 1, which is a simple point, coordinate point, it will print it is of type point and coordinates. Similarly, if we print line string 1, no, we have defined it as line 1, it is a line string with the coordinates. And if I print polygon 1, it will print the coordinates. If I print the multi-polygon, let me first print the polygon with the hole in it, so you can see this is the hole and this is the shell. Then you can print the multi-polygon 1. You can see the tuple of tuples, the level of tuples. You can see this is one polygon, this is the second polygon, and within this you have the shell as well as the hole. So that is about geom type attribute and coords attribute. Then we have a few more useful properties, like you can get bounds of any geometry, whether it is point or whether it is line or whether it is anything. Let us try to get the bounds of this polygon 1. You simply type the polygon 1 dot bounds property. It will create a rectangle, a bounding box which contains this polygon. Even points has has bounds. And to get length of any geometry, let us say line 1 dot length, length of line 1, which is, this is line 1, so we have line 2 also. So what happens in case of multi-line 1, if we get the attribute of length multi-line 1, it provides the whole length of all the subcomponents, component lengths also. So in that case, you can get the components, length of components, using this multi-line 1 dot geoms 1 dot length. Multi-line 1 dot geoms 1 length, and sum of this should be equal to this length. So that is how we can calculate length. Another attribute is area. You can get area of any polygon using this attribute area. In case of polygon 3, which has a hole in it with having the same outer shell as polygon 1, let us check its area. It should be uh, okay, polygon 2, we have to compare polygon 2 and polygon 3. Polygon 2 area is 50 and polygon 3 area is 32, and we should get the area of polygon 1, which is the smaller polygon 18. As you may see that we have defined the polygons in such a way that the smaller polygon coincides with the first one. The hole in the this polygon 3 coincides with polygon 1, and the shell of polygon 2 and polygon 3 are the same. So that is about area attribute, and we can get centroid. So since the polygon 1 is defined with coordinates on axis, x-axis and y-axis, on either side, the centroid should be 0, 0. We can check it. I think you have to list out the it creates a geometry. Operation of dot centroid, it has created a geometry, the point geometry. Now you check the type of polygon 1 dot centroid. You can see it is a shapely dot geometry dot point, and you can check the centroid. You can try to print this. Which will be a point 0, 0. So we can also have a buffer of any point. So I can create buffer of point 1, which is 0, 0 by providing this buffer is a method, it's not an attribute. So we can send the number of units inside the point, inside the buffer, which will have the same units as the geometry coordinates, and you will get a buffer of point is obviously a circle. You can also check a buffer of a line object, a small buffer. You can see on either side of the line string line 1, buffer has been created. You can also check whether and there is a concept called geometry collection. So you can, in the geometry collection, till now we have created individual geometries: point, multi-point, line, line string, polygon, multi-polygon. If we combine them, it will create a geometry collection. Say you can create shapely dot geometry dot geometry collection by passing inside it a list of point 1, line 1, multi polygon 1, and you can see you have a point, you have a line, and the multi polygon. It is a geometry collection. You can check the type. collection, we can assign it to collection 1, and you can print collection 1, and you can check type of collection 1, which is a shapely.geometry.collection.geometry collection, and you can print collection 1 to get the geometric coordinates, which you can see it is a geometric collection containing point 0 0 line string with these coordinates, then multi-polygon with these coordinates. In multi-polygon, you can easily identify that it has one polygon with a hole inside it and another polygon without any hole. Then you can check whether two geometries are intersecting, or whether they are crossing or touching, or whether one contains another, by simply using some functions. Like you can check whether as you can see, line 1 has the coordinate 0 0 and point 1 has the coordinate 0 0. You can check whether point 1 dot intersects line 1. It should give a boolean type boolean output. It is true because they intersect. Similarly, you can check other attributes: equals, then contains, crosses, touches. You can check whether line 1 crosses line 2, and they do cross each other or intersect each other. Yes, true. Then one final thing is distance prop method, which can be used to calculate to get distance between any two geometries, the shortest distance between any two geometries. If it is between points, it is very easy. If it is between two polygons, it is the shortest distance between the polygons. So let us and in case if a polygon two polygons intersect, then obviously the distance between the two polygons should be 0. So let us see the distance between point 1 and line 1. It should be 0, like point 1 dot distance, then line 1. It should give the result 0. Let us get some known distance value, say distance between polygon 4, which is this, and polygon 3. Whose coordinates in polygon 3 you have the coordinate 5 comma 0, and polygon 4 the coordinate 6 comma 0. The distance between these two is 1.0, shortest distance. Let us check it. Polygon 3 dot distance polygon 4 1.0. So let us move forward. That is about Shapely, which provides functions for creating geometries and applying geometric operations. For example, centroid, area, length. These will be useful. Let us try to create a geodata frame from scratch, making use of the Shapely geometries which we have created. Let me create a heading. Creation of geodata frame from scratch. So we have already created some geometry objects, Shapely geometry objects, which we will make use of
creating a geometry column for geodata frame. Geodata frame necessarily should include a geometry column. Rest of the things are similar to pandas data frame. So we will make use of two polygons which we have created as shapely geometry objects, polygon 4 and this polygon 3, which has both internal and external interior and exterior boundaries, a hole within the boundary within the polygon. Now for creation, we can create a geodata frame from a dictionary of lists, just as we had created a pandas data frame from list. Now only thing which needs to be taken care of is geometry column. Now I will define. Now let us see what do we have with us, the polygon 3 and then polygon 4, which will become part of our geometry. So we will define a dictionary gdf underscore dict with curly brackets. Now the value there will be key value pairs which will be the column headers, and then the values which are in the form of list. Now names, I can specify them as polygon 3 and polygon 4, and then next the geometry column as a key, and in the list we have to pass the shapely geometries polygon 3 and polygon 4. So this is, we have created a dictionary. Now the geodata frame can be created using, so before creation of geodata frame we have to import the necessary modules which we generally do at the top, but we have been only working with shapely. Now we will be needing pandas, import pandas as pd, and similarly we have a convention of importing geo pandas in a short name as gpd. So we have imported them. Then we can create a geodata frame with geopandas dot gpd dot. The available functions, you can have a look at the tab completion. You can create a geodata frame with gpd dot geodata frame, and you just pass on the dictionary, that is gdf underscore dict, and here you have to specify the coordinate reference system. In the shapely we had no concept of crs. Now you can define it as crs is equal to 4326. Now as I said, you have to be aware of some basic things like this 4326 epsg 4326 refers to the datum wgs84 datum, which, so we are defining the CRS also. Now let us execute this and let us print the geodata frame, a simple geodata frame which we have tried to create. Yes, it has been created just as in the case of pandas data frame. Indexing automatic default indexing will start from integer 0 and 1, then the name is the one column, which is this is a actually a pandas series, which is, and then we have geometry column with information regarding the geometry, the geometric information. This is the geo series. So let us check the type of GDF, whether the geodata frame has been created as a geodata frame. It is a geopandas dot geodata frame dot geodata frame. Then let us in the all because it is an extension of pandas data frame, all functionalities of the pandas which we have seen are applicable here also. You can select any column by naming by with passing the name of the column within the square brackets, and then you can check it is a pandas series by checking the type of GDF. It is a pandas series, as we have seen. And then let us also see this geometry. Let us also select the geometry column and check the type of geometry column. So GDF. So as you can see, the data type in case of pandas series is object, which is an object which is a string object. And here the data type is geometry, which is an indication that it is not an ordinary pandas series, but an geo series. It is a geopandas geo series. You can check that by typing type GDF geometry. So it is a geopandas geo series. So we have created a geo data frame from scratch. Now, since the geodata frame is an extension of the pandas data frame, all the functions or operators which are we have applied in case of pandas data frame are also applicable here. You can isolate any uh, element of the geometry using iloc operator GDF of, and you select the column geometry, and say in the first row we have polygon 3. You can select it by passing the row index, that is 0. So we, in this way you can this is a shapely geometry object. Now you can have a look at the attribute CRS of the geodata frame, which we have defined to be EPSG 4326, which refers to WGS 84 ellipsoid. Then we can also have visualization, visual examination of the layer using the GDF dot plot, which is based upon matplotlib dot pyplot submodule function. Um, so GDF dot plot, you can have visualization. However, here color is being uniform and you don't find the hole. So you can pass some optional parameters for better visualization. Uh, you can pass the color. There are two. You can have a look at the help option uh, if you need any information about the parameters, etc. And I think you can. The edge color is a parameter. Style options to be passed on to the actual plot function, such as edge color, face color, line width, marker size, alpha. So you can pass on the color, edge color is say red. Yes. So you have visualization of the layer using dot plot method. So that in this way you can create a geodata frame from scratch. So creating a geodata frame from scratch is just to make you understand the basic functionalities. In reality, we don't create any geodata base from scratch. We will try to read a vector data file, or we will try to create a new vector data file from a tabular data. So we will have a look at some more examples, some very basic examples, and rest of the thing, as I said, it won't be possible for us to explore all functionalities related to geospatial analysis. We will have a separate training program on geospatial analysis in Python, maybe afterwards in the next year. So let us try to see how, if we have a vector data file like a shape file, uh, how to create a geodata frame from a shape file. We will see that. So first of all, you need to have a shape file with you. What I have done is I have downloaded a shape file from authentic source, which is KSRAC, Karnataka State Remote Sensing Application Center. Go to this website, kgis.ksrac.in. You can simply do a Google search, and then in the download section there are shape files of district boundaries, taluka boundaries, even village boundaries. We will we will make use of district boundaries. Any shapefile, I have downloaded the shapefile on my system and have saved it in the data folder in our in my home directory in Python WRM. In data, I have created a subfolder Karnataka underscore districts and have placed the shapefile along with other associated files .prj for projection, .dbf, .cpg. So I have to remember this file path. Let us try to read the data. We have to create the file path first. So fp is, now before creating file path, let us also import the pathlib and os, and file path is, as we have done earlier, pathlib.path.home, which is my home directory, and I will use / operator to add the directories. Then data, then Karnataka districts. Data / Karnataka districts. Just take care of the names wherever you have upper cases and lower cases letters. Then finally the name of the file .shp extension, file district.shp. So I have defined the file path. Now I will make use of the function, the method in geodata frames, geopandas, geodata geopandas dot read underscore file file. You can one thing is, to tab completion, you can search for the method read file, and you can see the help option. You can make use of help option. It is the read file takes the file name, then bounding box, which has a default parameter none, then mask none, default none. These are some parameters which are already defined. We have to pass the file name, which is the compulsory parameter. Remaining are optional parameters, and it returns a geodata frame from a file or URL, either absolute or relative path to the file or URL to be opened. You can read about other optional parameters, and there are also examples. The geodata, if you go to GeoPanda's website, you will get tutorials for getting started other than the user guide. It is I suggest you go there and make use of the sample data which comes along with GeoPanda's installation, and you can use the Jupyter notebooks to run the same code, and wherever there is a need of modification. By now you are if you have attended the training program attentively, you will be in a position to even modify the code and then run the cell without even if you get an error, you can rectify it and you can run it. So you can go through the user guide and you can go through the examples, and you can explore many other functionalities, many other third-party packages which we have installed on day one for plotting purpose. We have installed many third-party libraries. You can also create interactive map. You can have a base map um, uh, as a background. So a lot of options are there for building up yourself through self-learning. So you can go there and you can have a look. So here let us try to read the file gpd dot read file, and you pass on the file path and you assign it to a geodata frame gdf underscore districts. So it will take some time, then you can check by printing it and then checking the, you can check the type of gdf underscore dists. So you have successfully created a geodata frame by reading the file, and this read file function, it can read a variety of vector data files, many common formats, not only shapefile, geopackage, geodatabase, KML, so many files it can read. You can print the geodata frame. So this is the geodata frame which we have created using the shapefile downloaded from Karnataka State Remote Application Center website. So you have the default index column, then object ID, then KGIS district code. I guess the name of the district is this. You can rename the columns as per the requirement. One is name of the column, then the other columns and you can see a column of geometry which is created, which is either multi-polygon or polygon. So a geodata frame should necessarily have a geometry column. So we have that, and I guess remaining columns, there are no, some columns are not of not much use when it was last edited, when it was created, etc. We can select the some columns and redefine the geodata frame. And I guess this is the area of the shapefile, the district, as, and this is the perimeter. I am not sure, but we can check. So you have created a geodata frame. Now you can make use of all the functions which were available with the pandas data frame. Like, you can have a look at all the columns. Okay, sorry, it is gdf underscore, we have create, the name of the geodata frame is gdf underscore dists. So you have object id, you have the district, the name of the district. You can again have a look. We will only select few columns, kgas district underscore 1. Then we will select this shape, then style, uh, star, this is I think area, then length, then geometry has to be there. So for renaming, we have to pass a dictionary of old names and new names. gdf underscore dists and underscore filtered. Let us select first the columns, gdf underscore dists, then you pass the column names. You get the object id. We will make it a index column afterwards. Then you get the name of the district. And you simply get the geometry. Area we will try to calculate on our own and compare with the values. So this is my new data frame, geodata frame. Yeah, you have to whenever there are more than one column, you have to pass a list of columns. If you remember, we have done that in case of pandas data frame. Then you can have a look at your new data filtered data frame. So this is your data frame. Then we want to set object ID as your index. So you can make use of the function set index. Set index, you pass on the name of yes. So you have got the index as object ID, and you can rename the columns as district. Rename this column as district. Hopefully we are doing the modifications in place, and the geodata frame is getting changed. No, it is not. It is so we have to save it again. And run the same cell. And then you print the data frame. Now we have to rename the columns. Rename the column whenever you are in doubt. Just make use of help option on what parameters to pass on, etc. So this is help on method rename in module pandas dot code dot frame. Rename the function or dict values must be unique, and if you remember, you have to pass a dictionary with the key value pairs as old name and new name. Something like this. So let us do that. Rename, and in parenthesis columns is equal to dictionary old name colon, and new name simply pass on district, and save it to so we have changed the name of the column, and then you have the geometry column. So this is the geodata frame which we have. Let us plot it, and let us see how it, and let us check what is the coordinate reference system, because we have downloaded it. We are not aware of the metadata. We will get the CRS. We can do that using the CRS attribute, the geodata frame dot CRS, which is EPSG 32643. So this is actually different from EPSG, the geographical coordinate system 3246. Um, this is UTM zone 43N, valid for a region between 72° east and 78° east. You must be aware of UTM. Or this is basically very useful for calculation of areas and lengths. So world is divided into many UTM zones. So this portion falls in this zone UTM zone 43 north. So let us then create have a see the areas. You can either pass on the geometry and then create and then use the area the otherwise or else you can simply um, make use of this area. So it has created a new series which you can actually save it as a new column of your data frame, geodata frame. Column column name will be area, and if this area is in meter square you can convert it into kilometer square. Whether we can do that in one go or we have to apply the function, let us check. You divide it by 1 e 10 power 6 e plus 0.6. Yes, so I have a new column of area in kilometer square with making use of this property, area property, and by dividing by and converting it into kilometer square. In fact, you can include the unit in the name of the column and then run again. Okay, a new a new column has been added. We can make use of You can verify these areas with our original shapefile, whether they match, like B Belgavi 1.33 into 10 power 10. Yes, because they are in the same projection system, CRS. They are the same values. So you can verify which is the maximum, which is the area district with maximum area, etc. You can get basic statistics also. However, we want to remove this column area, which is redundant. If we explore the functions, if the function pop is there, we may use of it, make use of it. Pop, let us try this. Has to go in within parentheses as it is a function. It is not valid. You get help. So for example, if you have a data frame of this, you want to, okay, you can simply pass within parentheses the name of the column. And you save it. Okay, the problem is you are running. I have run it. I have been running the same cell twice. So after popping out the area, it is unable to find the area the column again, as I am running for the second time. No issue. You can print the data frame. I can't. I'm unable to understand. Only object ID is remaining. Okay. Let me do one thing. Let me restart the kernel. I think I haven't shown this option. Whenever you want to restart, you can clear all the outputs, or you can run all the cells again. So it will start running the cells from the beginning. So we have filtered the columns here, and then we have renamed the columns. We have made object ID as the index, renamed the column to district, and then we have seen the CRS, and then we have calculated the area, and yeah. So now we have our geodata frame in this form. Let us see some basic statistics on some basic checks of our data geodata frame. You can check first 5 rows using this, and you can check the basic description of the geodata frame. Basic statistics, only numerical column statistics will be printed. So there are 30 districts. Mean area is not much useful to us. You can see that maximum area is 13,339 square kilometers, and minimum area is 2,195 square kilometers. So you can check 13,000. The Belgavi is the largest district, whereas Bengaluru urban is the smallest district in terms of area. So in this way you can check the data, and then you can plot. So you can have a visualization of the layer at hand. While plotting, you can also give various options of colors, edge coloring of edges. Then you can also plot by values. Like you can pass on the parameter column. The only column which you have is area in kilometer square. Then it will take the area into account, area of each. So the largest area is shown in yellow, bright yellow, and the smallest district is shown uh, in dark blue, and there is a variation of colors as per the area. So if you go to this matplotlib.org website, there you can go through the documentation where you have this matplotlib we have installed on the day one. It is a comprehensive library for creating static as well as animated and interactive visualizations in Python. There are so many examples, you can explore it. Even for tabular data, you can create very beautiful charts and graphs. The source code is made available here. You can simply copy and paste in your Jupyter notebook, make necessary modifications as per the data you have, and then try with various visualizations. So that is about reading a vector file. So let us quickly go through another application using GeoPandas. Creation of the vector layer from tabular data or from the text data. I have provided a new data file, Karnataka dams file. taken from National Register of Large Dams, where there is information about large dams located within the state of Karnataka, along with latitude and longitude information, which will be needed for us to create geometry and much other data like storage capacity, dam length, height above the foundation level, dam type, river basin, nearest city, etc. So let us first create a data frame, pandas data frame, and then try to create a geodata frame from pandas data frame, and let us try to export the geodata frame, write the geodata frame into a file, vector file, shape file. So first we have to define the path. Pathlib we have, I think we have already imported it. I will give the heading creation of vector layer. So file path underscore dams, from home directory there is a folder python wrm, and then there is a folder data. Now let us see where the file is. The CSV file is inside the data folder. So I will provide, so this is the file path. You can check Windows path has been created. Then we will create a data frame, pandas data frame, by using pd.read csv function, which we have seen yesterday. And I will pass the file, and because it is a tab separated file, you can also give the parameter sep is equal to \t. Then you can execute, and then print the data frame. You can quickly check, there are 231 rows and 20 columns. You can quickly check the data frame, pandas data frame that has been created with info method. So there are 231 entries, there are 19 columns, PIC, that is ID, which is an object, that is string, name of the dam, operated and maintained by, that is again a string, latitude and longitude, they are floats, year of completion, it has taken it as float, however it should have been integer. Then river basin, river, nearest city, seismic zone, dam type, these are all floats. Then height, dam length, volume, content of the dam, gross storage capacity, reservoir area, effective storage capacity, and design spillway capacity, these are all float data types. Then purpose of the dam, this is again object data type. So there are this is about the data frame. You can also check basic statistics. Of importance are maximum and minimum values of height, storage capacity, etc. We have to see. So you can see that minimum storage, maximum storage capacity 4.4 BCM. then height 108 meters. So the same functionalities, same operations which you have conducted on the another file yesterday on data frame, you can make use of it and you can check and you can filter out the columns which are all columns you wanted to include in the final shape file. I am not doing any filtering for now, and I will just go ahead and create a geodata frame from the data frame. Now for that I have to first specify the coordinate reference system, and then I have to create a geometry column and add to this data frame. Now for creation of the geometry column, there is a very convenient method in geodata frame, geo pandas, which is known as points from xy, and you can check help option on what this function does. So this generates geometry array of shapely point objects from x, y, z coordinates. Now z coordinate we haven't used it till now. We are not giving it. In shapely geometry objects, we can also add z coordinate by specifying the. So this function you can add the comment points from underscore xy. It generate geometry array of shapely point geometries from xy coordinates, and it will take um, data frame dot longitude, data frame dot that latitude, as well as CRS. So let us do that. So geometry, I am defining it as GPD, short for geopandas dot the function points underscore from underscore xy. Our data frame name is df underscore dams. Longitude will come first because x coordinate on x axis we will be longitude will be varying, and on y axis latitude, and then CRS, yes, we will go with 4326 as we are dealing with geographical coordinates. So data frame object has no attribute longitude. Yeah, now what is the we have to check the how the longitude and latitude are represented here, and you have to take the same form, latitude and longitude, and run it again. So we have successfully created a geometry array. We may try to print it. It is a, you may check the type of this, which is a geometry array. Then we will create the our geodata frame gdf underscore dams is geopandas dot geodata frame, and in parenthesis you pass on the original data pandas data frame which we have created after reading the file. Then CRS has already been defined, then geometry. Let us unhashable point type point. We have made some mistake. PDF dams is gpd.geodata frame. Yeah, let let's term this one geometry 1. Run the cells again. Geometry is geometry 1, and df dams gdf underscore dams. Yes, we have created some table. If you find the column geometry attached, then we have succeeded. Yes, a new column geometry is added to the original pandas data frame, and now this is geodata frame. You can have a check. Type of gdf underscore dams, which is a geodata frame. You can even check the coordinate system gdf underscore dams dot crs, which is geographic coordinate reference system EPSG 4326. That is all right. Then now we have to write this geodata frame data into a shape file. Let us create an output put path, just as we had created a file path for inputs. Copy. So call it output underscore fp underscore dams. So in the home directory in Python WRM in data, where you want to save this, you have a check. You may want to save it because it is a shape file. It will be saved along with associated files. You can save it in a separate folder. Karnataka dams. Then Karnataka dams. Then you give the name of the shapefile, Karnataka underscore dams underscore nrld dot shp, or make it short, Karnataka. So we have created an output path. Now we have to write the geodata frame gdf underscore dams to file. You say similar to read underscore file, you have this to underscore file, which is a function which can write the data into different formats. That by default it is shapefile, so you can pass on this output put path and run. It is giving a warning. It's not an error. It is saying column names longer than 10 characters will be truncated when saved to SRE shapefile. We have given a long name. Anyway, let us check the whether the shapefile has been created or not in our folder. Yes, it has been created. We can check it. I have opened QGIS, which is an open source GIS software, and I will So this is the uh, shapefile which we have created from the tabular data, and you can do the check. So you can see that the information about the dam is stored in the attribute tables, the information which we have provided, PIC, name of the dam, operated by the same in the same order, in fact. So the file has been generated. Let us check by okay. So I have also taken input layer of districts, and I'm making it transparent. So you may check that the shapefile which has been created looks accurate. If there is any known dam, like in Mandya district, we have the Krishnaraj Sagar Dam. Yeah, K.R. Sagar Dam, which is on Kaveri River, Mysore Mandya border. So we have created a new vector data shapefile from the um, tabular data from the tabular data. I think we can conclude this session here, as this session is meant to be a introductory session to geospatial analysis in using Python, working with vector data. We have seen the basics of shapely geometry objects, and the GeoPandas, we have seen the basics, how to create geodata frame, which is an extension of the Pandas data frame. Pandas data frame, we have covered many functionalities. All of them will be applicable here, and we have seen how to create how to read from a vector data file and create a geodata frame, or how to write the data from geodata frame to a vector layer. So you can explore further. It is suggested that you go to the website of GeoPandas, where you will find getting start, and in the getting started tab there are example galleries, where you will find many examples, overlay analysis, overlay functions, clipping of vector data, the basic GIS functionalities. You can automate them using Python. You will find the source code, and you will find various plotting options, spatial joins, table joins. There is lot much to explore. So please go through, and you can go through the user guide also, uh, which has description of the functions along with example data and code. uh, that's it for this session. Thank you very much.